This is the 6th FRQ from the 2015 BC exam. So they give us a series right here. They give us the terms of the series written out. The first thing they ask us to do is use the ratio test to find R. So I'm going to go ahead and write the series a little bit differently because I don't like it written like that. All right, so the ratio test says the limit as n goes to infinity of -3 to the n plus 1 minus 1 x to the n plus 1 over n plus 1. And so it's, if you guys remember, you plug in n plus 1 for each of the n's, and then you divide that by everything with the exponent that it actually had. And then because it's a fraction, we keep change flip. And so I'm just going to go ahead to save space. I'm just going to flip that up now. And as long as you don't make any mistakes, you get those points. So the limit as n goes to infinity of, those cancel, -3 to the n, x to the n, x to the 1. -3 to the n, -3 to the -1, x to the n. So I'm just kind of splitting everything apart so you guys can see how I'm about to simplify and reduce. So the -3's to the n, those cancel, x to the n. -3 to the exponent of -1, since that's on the bottom, I'm going to go ahead and move it to the top. So I have the limit as n goes to infinity of -3 to the 1, then I have an x and an n over n plus 1. If I plug in infinity, this n and this n basically are the same size, cancel out, and so I get the absolute value of -3x, and so that's just 3x. So to calculate the radius, we know that this converges if this is less than 1. And so I'm going to say absolute value of 3x is less than 1, divide the 3 over x is less than 1/3. So the radius of convergence is 1/3. And that's all I had to find. We didn't have to find the interval of convergence. We just had to find the radius of convergence. And so that problem is not as terrible as it could have been if they wanted us to do more. All right, part B says to write the first 4 non-zero terms in the Maclaurin series for the derivative, and then to express that derivative as a rational function. So I'm going to go ahead and take the terms that they gave me. They said that f of x is x minus 3/2 x to the second plus 3x to the third. Just realized I don't have 4 terms when I did this before. You know what I'm going to do is I'm going to go ahead and let's maybe write one more term so that we have the first 4 non-zero terms, because this only has 3. So I'm going to put one more and then I'm going to put the general term. So we had n equals 1, so this must be n equals 1. Yep. N equals 2, n equals 3, so n equals 4 would be, I'm going to write it up here, -3 to the 3 divided by 4, x to the 4. Okay, so that's 27/4 x to the 4th. Okay, so there's my 4 non-zero terms. That was tricky of them. I wonder if they would actually grade down for that. That's rude. All right, here's my nth term. Okay, so that was the function that we started with. We need to take the derivative of it. That's not bad, we can do that. Derivative of x is 1. -3/2 multiplied by 2 is -3, x to the 1. 9x squared, multiply the 4. When I multiply the n to the front, it's going to cancel with the n on the bottom. So we're just going to get negative 3 to the n minus 1, x to the n minus 1. Okay, so there's our derivative right there. And then when it said to express f prime as a rational function, this is where, and it's funny because I did these problems last year too. I could not figure it out last year, and I looked at it this year and I was like, but that's not a rational function. And I totally missed it both years. So hopefully when I do these problems next year, I won't miss it. But what you have here, once I looked at the answer key, I was like, oh, they're so tricky. Is you have this series, negative 3 to the n minus 1, x to the n minus 1, and since they have the same exponent, you can put those together. So you can say negative 3x to the n minus 1, and then, aha, it's a geometric series. So now you can say, all right, my first term, if I plug in 1 here, I get 1 minus 1 is 0. Anything to the 0 is 1. My r value is the stuff that's being raised to the exponent, so my r value is negative 3x. And so if you guys recall, the sum of the series is the first term divided by 1 minus r. And so the sum of the series would be 1 over 1 minus negative 3x, and whatever the sum of the series is another way you can express the function as an equation instead of as this polynomial. So this is the polynomial, right, if we are finding an approximation for it, but if we want to know what the actual function was, it was this rational function that would give that. So that was kind of tricky. No judgment if you didn't get it, because I didn't either 2 years in a row, even though I'd seen it before. All right, Maclaurin series for e to the x. We've got 1 plus x squared over 2 factorial plus x to the third over 3 factorial. Okay, and then they want f of x as well, which I'm just going to write these down real quick. I'm only going to the third power because what they actually want from this is they want us to find g of x, and g of x is these two multiplied together. And you cannot just be like, oh, multiply those, you cannot do that. You have to FOIL this. Okay, so I'm going to go ahead and do a box to FOIL this because I find it easier to organize the information. And because the highest exponent that I want is a 3, that's why I used up to the third power in both of the polynomials. All right, so x times 1, negative 3 halves x squared times 1, 3x cubed times 1, okay? X times x, negative 3x squared times x. Don't even have to do this because that's bigger than an exponent of 3, so I'm not even going to multiply that. X times 1/2 x is 1/2 x to the third. Yep, yeah. Not even going to multiply it. Turns out I didn't need that term at all. Okay, so g of x is x squared, so we've got negative 1/2 positive 1, so negative 1/2, positive 3, negative 1/2, positive 1/2, so that's negative 1 and 3 is 2, so plus 2x to the third, and there's your g of x. And look how not terrible that was. It's pretty okay.